Two formulae to be aware of when working in radians and sectors are the arc length, which is equal to r theta, and the area, which is a half r squared theta. Let me just show you where these come from. So the arc length in general is going to be the angle divided by the whole angle in the circle, or around a point I should say, which is theta over 2 pi. And then we times by the circumference, 2 pi r, and the 2 pi's cancel, leaving us theta r, or r theta. And the same goes for the area. We've got theta over 2 pi, times that by pi r squared. This time it's just the pi's that cancel. We're left with a half theta r squared, or half r squared theta as I've written it here. So let's put these into practice. We're asked to find r and theta, and we're given that the arc length is equal to 15. So 15 is equal to r theta. And then the area is 45. So 45 is equal to a half r squared theta. I'm going to times through by 2 on this latter one, I think. So I'm going to get 90 equals r squared theta, which I could write as r times r theta, because now I can basically substitute in for r theta. This bit here is 15. Of course, you could just make r the subject, substitute that in, and it'll cancel out. But if you can spot to just replace r theta, it seems to be a little bit quicker. So r is going to be 90 divided by 15, which is 6. And then theta is going to be 15 over 6, which I can divide through by 3. So it's going to be 5 over 2. Okay, happy with that. I'll just leave them. I could write 2.5, but I think I'm okay with 5 over 2. Finally, we're asked to find the area of the segment bounded by the arc AB and the chord AB. Okay, here's the chord AB. So we're being asked for this area here. Actually, let me do it in red. So this is going to be the area of the arc, which, as we've seen from before, is 45. And then we're going to minus the area of the triangle. Okay, now we know a lot about this triangle now, because r is 6. So this is going to be 6, and this is going to be 6. And then theta is 5 over 2. Okay, so I've got a triangle with two sides and the angle in between. I can use half AB sine C, the area of the triangle. So it's going to be a half times 6 squared times sine 5 over 2. I'll need my calculator for this. Now don't forget to put it in radians. You go to shift and then you set up angle unit and then it's there. Okay, just be on the lookout for these sorts of questions with angles and you're finding sine or cos and so on. So it's going to be 45 minus a half, just write 0.5, times 6 squared times sine 5 over 2. And this gives 34.227, which I will round to 34.2 centimeters squared. Nice one.